Hello everyone, you're all welcome to week 5, day 2. Yesterday we talked about system functions and we started off with the date and time functions. One thing is common to all of these functions we did yesterday. They all work on date and time fields. So the columns we use in these functions were all date and time columns. Today we're going to move to numeric functions. We're also going to look at string functions. Just like the name says, numeric functions, they're going to act on numbers, columns that are hosting numbers. These are columns that are hosting strings, string functions. We're going to see that. For the benefit of those who missed the class yesterday, I'll begin with this revision right here. So if you go to the lecture materials, it's a review on date and time functions. We're just going to begin with that one. So let's open that SQL file. And if there are any questions on the functions we did yesterday, we can address them. But let me begin by projecting this review. This is the two, yes, this one right here, review date time functions. I think we all have this database, human resource. It's been a while we've not looked at it. So human resource is this one. So just connect to it. You can just review. There are two tables. We have the employee table and the project table. All right, so employees are basically assigned to projects, and these two tables are tracking those information. All right, so let's take an example. Yes, I did do a join, an inner join between the employee table and the project table. And that inner join goes through I think the employee ID is right here, employee D2 ID right here, same information, right? So basically these are the employees and these are the projects they are assigned to. Yes, so what columns did I make use of? It's definitely going to be the date columns. For example, the joining date. Yes, we're going to explore this column to demonstrate the date time functions we studied yesterday. So the first one that is easy, we talked about this function yesterday. This is a function that returns the current date and time. And this function takes no parameter. You don't specify anything to the function. And by the way, every database has a folder called programmability. And if you expand on programmability, you're going to see functions, expand, you're going to see system functions. This is a topic we are studying. And if you expand on that system functions folder, you see functions are divided into different categories. We are familiar with aggregate functions. There are 5 key aggregate functions we studied: average, count, max, mean, sum. Right. Every other one that is omitted doesn't have like business implication. So the 5 ones with key business implications are the ones we studied. These are aggregate functions. And then yesterday, these are the ones we saw, date and time functions. So I'm not exposing you to all the functions. I'm basically addressing the key ones that you have to know. Right, we talked about date. Let's begin with this right here. I'm just going to point to the function, this one. We talked about the get date function. It's just to return current date and time. Right. So if you just do a select and you just call the function select get date, you end up getting the date and time as of your location and also the way your laptop is configured. Right. This is the get date function right here. Right. And so if you add that in a table, in a query, this is just going to print out a new column called current date, and it's just going to print out the current date as of the time the query was executed. So if I go ahead and run this query, let's just no, not everything, let's just highlight this part all the way to this and execute. Right, so you see a new column has been added. I'm looking at this one. So after the joining date, this is the joining date column, this is the current date. So this column right here is a new column, is built on this logic. It's just showing me the current date and time. Right, this is the current date and time, the time that query was executed. See? Right. So that's all about this function. Right. Whenever you're facing a scenario you want to return the current date and time, think about this function. That's the get date function. This is it right here. Where's that? This function, if you expand, You go to the parameters, expand. The arrow pointing inward is called the input parameter, what you specify inside the function. You see, it says none. That's why this function is empty. So it takes nothing, but what does it return? This is a return output, the return parameter. It returns date time. So this is what we get. We get the date and the time. See that? So every function, you have to know these two things: what the function receives and what the function returns. And that's what is captured on the parameter section. This function takes nothing. That's the input parameter, is none. It returns what? The date and time. These are the date and time you see right here at the time of execution of the query. So that's the get date function, right? Now, this function we also saw yesterday is a simple function. It simply goes into the joining date. That's a column right here. You see, it gives you the year, the month, and the day. And this function is interested in just extracting the year. And we are creating a new column called joining year by using this function, which simply goes into the joining date column and extracts just the year. So this value, extracting just the year, we get this. This right here, extracting just the year, we get this. You see, that's how that column is generated. It visits each row, each value in that column, and extracts just the year. That's what the year function is doing, right? So if I give you an example on that year function, this is it right here. Just place your cursor on it. It tells you it returns an integer. So these are integers. And that integer is the year part of the date. So these are different parts of the date. You have the year, the month, the day. The year function extracts only the year part of the date. Right? This is very important. And that's what you get right then. Same thing with the month function. It extracts just the month part of the date. This is the date, the joining date. Just go and extract the month. This is second. Oh, this is February, sorry. Right. You see the extraction right there. This is all January, and that's what you see right there. If you want to print out the actual name of the month and not just the number corresponding to the month, you have to use the date name function. And you specify the system you want to return the name of the month. And this is what this function generates: a new column called the joining month name, this one right here. So why the month function is giving us the integer between the integer from 1 to 12, that's 12 calendars month. The date name function is gonna return the actual name of the month. So this is the numeric version of the month, second, that's 2 for February, but the actual month name is February, you see. And then of course the day function simply goes into a date and returns the day. This is the 15th day of the month of February of the year 2013. So this is the joining day. This new column created is just outputting the day 15, you see that, which is coming from this column. So those different parts of a date can be extracted using those key functions. The year, to extract the year function, the year part of the date, we use the year function. To extract the month part of the date, we use the month function, like what we're doing right here. To extract the day part of a date, we use the day function, like what you see right here. Right, this is very, very interesting. And then we saw some two analytical date functions which perform calculations. We have the date diff. From the name, you can easily tell what it does. It looks at the difference between two dates. And what is the business reason behind this process is to look at what the duration. If I give you two dates, this is the joining date and today's date. So from the time this employee joined the company all the way to today's date, how long have they been in the company? And this is what called the duration in years. So this is used to quantify that number. 5 years is different from 5 months, it's different from 5 days, stuff like that, you see. So if it tells you to calculate the duration in years, you're gonna use the date diff function, put year, and then you specify the start date and specify the end date. And the system will calculate the duration between this start date and this end date. and the answer is going to be projected in years. See that? And this is exactly what we're getting right here on the date diff, the duration in year. What's that column? This one. So from this start date, that's the joining date, all the way to current date, which is this person has been in the company for 11 years. From this all the way to this is 11 years. Well, how do you know it's years? Because we specify year right here. I can change this to month and execute this query. The result will be different. So that is where you quantify the outcome. You see that the values are much bigger. This is now duration in month. All right, let's go back to the year part. So in the duration, that's a date diff function. There must be a starting date and there must be an ending date. I'm using today's date. That's why I'm using get date. And so it will simply go there and calculate the number, in this case, number of years from this joining date to this current date, today's date. Right? And that's what we get. So this is a duration in years between 2013, this date and this date. How many years have gone by? 11 years. Right. So that's the date diff function. Right. Use this whenever you're asked to investigate the difference between two dates. There's something I have to mention. You cannot look at the difference between two days by just subtracting them. So maybe the joining date minus the get date. Some other programming languages support that. Let me demonstrate that. So for example, you see what we did right here on the date diff, joining date and then today's date. I just copy those two and I do a deduction like this. There are other programming languages which will support this behavior. Right. I get an error right here. Let me just double click so that you can see the line. Yes, this is complaining about this line. So you cannot just take a date and do a subtraction from another date. All right, so to do this, you have to go to the date diff function. Right, so this is very important. And next, we have a date add function. You simply add, right? This word should not mislead you. You can do both addition and subtraction. So you're adding, in this case, you're adding 2 years onto the joining date. So from when the employee joined the company, add 2 years to that date. Why the date diff gives you a number, an integer, you see, it returns integer. The date add function returns a date. If you add 2 years onto a date, it remains a date. You have a negative sign, you're deducting 2 years from a date. So the date add can perform both addition and subtraction depending on the sign of this quantity. If this number is positive, that's an addition. So we are adding 2 years onto the joining date. If this sign is negative, that's a deduction. We are deducting 2 years onto this. This can also be months. I can switch this to month. You can deduct 2 months from a date. You can deduct 2 days from a date. So you have to be very careful when you're reading the requirement to know exactly how to code this. Right. So this is quantified by this. If the sign is positive, it's an addition. If the sign is negative, it's a deduction. Let me project this so you can see. So pretty much this is what we studied yesterday. See this? This is us adding 2 years onto the joining date, and that column is coming from this process. And this is the joining date right here. Add 2 years onto this date. This is 2013, 2015. On this one, we are deducting 2 years. That's joining date minus 2 is this date. Minus 2 years, we are back to 2011. See that? So there's nothing like a date sub. For example, we want to deduct, you're not going to put sub right here. Somebody wants to ask me if this is possible. So date add function will do both addition and subtraction depending on the symbol this carries. Right. So this is something to remember. Right. So with date add function, you're adding or deducting a quantity from a date. And you have to remember a date add function returns a date. These last two columns are derived from date add function. And you see that the answer or the return, the output is a date. This column right here is a date diff function. The output is an integer because we're looking at the duration between two events. See, the duration between two events, subtracting two dates does not give you a date. It gives you an integer. Right. Okay, any question on this? Let's just take one more question on this. Write a SQL query to print the details of workers who have joined the company in February of 2014. February, that's the month. If I'm using the month function, I cannot type February right here because the month function returns what? It returns an integer. And the integer that corresponds to February is the number 2 on the calendar. Right. So if you choose to solve that question like this is fine. If you want to go with the February route, then you have to transform this into a date name function and then tell the system the date name you want to project. It's the month part. You see the transformation? And now you can equate this to what? February, because you've transformed this part into a string. It is giving you the name of the month. 2 is not the name of a month. Right? This should be replaced by February. So you have to watch out how you use this. See that for the year, yes, there's nothing like the name of a year. Year is just always going to be integer. You see that? So this is how you go to the joining date and transform it to a year so that this part is equal to this part. You cannot put joining date like this equal to year. You have to know when a part of a date is projected, not the entire date. So these are date extraction functions. They extract parts of dates. You're dealing here with the full part of a date. Right? If I run this, you see the joining date is actually a date. It has the year part, the month part, and the day part. So you cannot take 3 components and equate it to a single component. How do you balance this equation? You have to make sure that this is transformed to only extract the year. Because why? This is a year. And that's why we use the year function on this side. So this is just to help those who missed the lecture is to catch up right this right here. You see that? So if you're on this dimension and you use the month function returns an integer. And that's why we're putting an integer 2, which represents the month of February. This gets the job done. Actually, nobody was hired in that month. Right, let me just go see if we can switch this. What dates do we have? This is 2014. Let's switch it to January. Right, in January. Right, so in this scenario, you cannot type January right here because you're using the month function returns an integer. January corresponds to 1 on the calendar, and this will give you the list of employees who joined the company during the month of January of the year 2014. And if you go to the join date, you see that it fulfills that condition. Every single one of these was, meets that criteria. The 2 mandatory, we have the and right here. On this side, we can do the same. I'm just going to switch this to what January. Right. And this is it. See that? Let me demonstrate one more example and we can. I'm interested to see the total sales and total profit for each year. Right. Use Global Superstore and write a query which will give the total sales and total profit for each year. Let's do this total sales. Total sales and total profit. Yes, so the manager wants to know this information. Let's build a query that will give us this. Use global superstore, use the orders table. So use global superstore, and switch this, and then use the orders table. Let's get to work on this. Once somebody's done with it, just let me know so I can share the screen. Let's address this, and then we can continue the plan for today. So the table we're going to be using is the orders table, right here. Yep. So that's the first question. I'll make this 2. And this one, I'm going to modify it to total sales and profit for each month of the year 2014. Right. So these are the 2 questions right here. Let me just share this on the chat window. I'll give you some time to work on those. This will give those who miss the class an opportunity to catch up. And while you're building that, I will connect to I'll connect to Tableau and build a visual for that process. So in this, we're using Global Superstore. And we're using the orders table. Okay. So the first question was total sales. So sales and profit. I'm gonna use total sales and profit. Okay, I'll just put right here total sales and profit. Total sales and profit by year. This is the first one. Total sales and profit by year. Okay, let's check out the first one. Want to share their solution for the first one. This is total sales and profit by year. And on the visual, this is what we expect to see. Total sales and profit by year. So I'm using a bar chart. This is visualization, right? So you can see each year you have from 2011 all the way to 2014. And on each year, you can see the two bars, one representing the profit, and one representing the sales. Right. So this is what I want you to build in SQL Server. Right. So you're just going to build a query, but then when you're visualizing it, you can now choose an appropriate chart type to use. This is a bar chart. That's the most commonly used for this kind of scenarios. Right. So this is what you're going to do in the second model. But for the first model, I want you to be able to build that query. Right. So can somebody share their solution for this? Total sales and total profit for each year. We're using the global superstore database. We're using the orders table.
I can volunteer.
Okay, Alex, I'm going to share your screen. So watch and then compare with your solution. If you have any challenges, you can just ask questions.
Hold up. Can you guys get me?
Yes, we can hear you. Yeah, and we can see your screen as well.
Okay, perfect. So let's see. The question was to find the total sales and profit for each year. Oh boy, I think I actually forgot to do the profit part as well. I bet I can do that on the yeah. Okay, let's see this 1 second. Actually forgot the profit part of it, but I can do that while we are on it. So, but
Okay.
yeah, either way, what I've done now it's like only for the sales. So what I did was to and since they ask for each year, like the process is more or less like similar to what I've been through earlier, but now the only difference is like trying to like extract the year from the date column. Because if we check just the select stuff models, then let's see, because the column was supposed to extract the year from is well actually I used the ship date for the year, but I don't know. Let's see.
Oh yeah, I
So
wasn't.
that's it.
Yeah, I wasn't very
Yes.
specific. Yeah, you can use. Yeah, you can switch it to the other date. I want to see.
Okay, the other day.
Yeah,
Okay.
normally I
So
was
I use,
supposed
I,
to.
I use the ship.
Yeah, I was supposed to.
Let's
Yeah, just change it to other
okay.
date.
It's spelled here other day. Okay, there we go. Yeah, okay. Given we're using the order date, we're trying to to extract the year from the order date column, which like it's so what I did was to use a year command or the year yeah, the inbuilt function in SQL year. Then now you specify the column you're trying to like get data from, which is then the order date. And I've alias mine year. Um, so as you guys can see, like all this, like the formatting, like on the first line, I use the format. That's just the extra stuff because I always prefer to have mine like concurrencies. But yeah, but either way, we're checking for the sales, which is where I have some sales. Then I've aliased it as total sales. Then in the grouping, I've grouped mine by year to kind of put all the sales in together per year. But since I forgot to do the profit part, let's see if I can do this on the. Okay, then let's see. Guys should bear with me. Let's see then. Okay, quantity sales. Okay, let's do the sales first. Sales is. I've seen now a bit sales.
Oh,
How is this gonna
you
be?
you have the sales part. You just have to add the profit. So I
Yeah,
see
the
where you
pro.
have this total sales here.
Oh, true, true, true. Okay, then let's do this. Wait, but I have the profit already, so I don't have to do any calculation. Yeah, profit, and then we do. Then we do the
Right. Yeah.
sum of profit. Then I'll label this as just profit. Then I need to go. Let's there's a comma here which is not supposed to. Oh, let's order the reason because. Oh, my bad.
No, can you replace the group by the ship date on the group by?
Oh, that's why. That's why. Okay.
Yes.
Oh,
Yes. And there's one
oh,
thing
this
called double date here.
yeah. Okay, okay. I see that.
Yeah. Excellent. So
Let me just format this as well. I'm on it. But this should be it. Yeah.
okay, fantastic. Yeah.
Then I don't know maybe what I wanted me to order by yeah, I ordered by year, but let's do by by total sales perhaps. So I
Okay.
should get the oops.
Right.
Oh, descending, I forgot to specify. But this was my thinking, and this is what I my solution. So yeah.
Yeah. This is excellent. Yeah. Okay. Awesome. Let me share my screen. So any question for Alex? I'm just gonna repeat exactly the same thing he did. So if you look at if I just go back to this and isolate the three columns we need in their raw form. So we need something like the order date, right? I'm just pulling up the columns in their raw form. We have the order date. We're gonna need the there's a sales. From there, we're gonna do total sales, right? Next, we need profit, which we're gonna use to do the total profit. These are just the three columns in their natural state, right? But the question talks about total sales. We have sales. How do we get to total sales? We need to use the sum function, exactly like what he did. So sum on the sales, right? And this is going to generate this new column called total sales. So summing up all the sales, get the total sales, this one, right? Same thing on the profit. You're going to sum up the profit in order to get the total profit, right? And I'm just going to go ahead and alias this as well. This is the total profit, right? And if you notice, the question was to depict these two quantities for each year. But if you look at the order date, we are seeing the full date. We are not interested in every single component. We just want the year part, right? So we're going to be going to order date, and we're going to be applying the year function to it so that we can extract just the year part from the date. And this is going to be the year.
Hey, hey, hey. Wait, my bad.
So this is what we're going to have, you see? And these are those three things we've done, you see? So we've done something on each of these columns. And now this is where you're going to realize that if you execute this, you get an error. And the error is simple. We have two aggregated columns, but then this column has not been aggregated. There's a function on it, yes, true, but it's not an aggregate function. So you have to copy this logic you see right here and put it in the group by. That's exactly what Alex did. So this is very important. All right. Don't be confused on the fact that hey, there's a function right here means that this column cannot go to the group by now. This is a non-aggregated column. This is a function true, but this function is not an aggregate function. This and this are aggregated, so we don't need to put them in the group by. Right. So if I take this and execute, we are now showing for each year, we are summing up all the sales for that year to get this single value. And then we sum up all the profit as well. I missed something right here to get this. Right. So this is very, very important. And I try to build this visual because you're going to get to that. This is a stack bar chart. You see, normally we have the traditional ways that we have a single bar on each category, but then since we have two bars stacked on the same position, it's a stack bar chart. You're going to build this visual in the next model. So you see for 2011, you see right here, you see the total profit, which is this, compared to the total sales, which is this. And you're doing that for each year. And if you look at Tableau, is also using the same function, the year function applied to the order date. See, if I double click on that, you're going to see that, right? And that's the same thing we are building, right? So when you understand SQL very well, when you start building these visuals in Power BI, you're going to understand exactly what's going on behind the scene, right? So all those sales numbers are summed up for each year, right? So we are summing up all this for each year, right? And you don't see any year occurring more than once. Why? Because of the group by. We take all the orders that came in the same year, we put them in one group, and then we visit each group and do the summation. Right, this is very important. And so this is what we end up getting. So if you didn't know about the year function, this is a date function, the date time function, you will not be able to solve this question. Right, this is very important. And then he did the formatting. I think we're going to talk about as a function we're going to address. It's we can consider it under the string functions or numeric function as well. Right, and you're going to see a lot of formatting when you're building visualizations. I think I did one of those in this. See that this axis is formatted, and you just have to target a certain quantity, and you just go ahead and do the formatting on that. If I target this, see there's a format button right here. I want to go to format. See, I can go to the number side and I render this as a currency. Traditionally it's US base, the dollar symbol is right there, and that's it. I'm putting it to decimal places. You see, that's already formatted that column. Right. So this is very important. I don't really bother a lot about formatting on the SQL side, but sometimes if you want to just share an output with your manager, and you can go ahead and do some formatting on it, it will enhance the aesthetics, the presentation about that particular stuff. So on the formatting side, that's when you can transform this. Hey, I want to transform all of this. I want to format it. Right. I'm just going to extract this and then I call the format function. It's a very simple function. Open and close the parentheses. Paste what you want to format, put a comma. I want to format this as a currency. I put C for currency. See the transformation right there. This has been formatted. This has not been formatted. You see how presentable this one looks. See? Now, if you want to do the same, you can remove this, or if you want to keep it in place, you can just type around it, format. I want to format this. You see, this you have to be careful with this because of the parentheses. That's why I like to copy and then paste. Right. I want to format this as a string of currency, C's of currency, and that's it. So if you run this version, this is the formatted version, you see. And you can then copy this output and send it to your manager. Right. But then building as a visual and see how nice this is. This is what companies want to see. See that? So I promise you, you're gonna have a lot of fun on the second model, but then you have to understand the SQL behind this process. That's what we are trying to build. See? Right. Okay, if this is understood, we can now do the second part. In the second part, we are looking at total sales and total profit for each month. And I want us to focus only on the on the year 2014. And I did put together this visual total sales and profit by month for the year 2014. And what you see important is a filter right here. See, so if I'm putting the requirements for this particular visual, I will have to start by focusing on 2014. So in visualization, we call that a filter, right? In SQL, we call that a condition. This is a filter. You see, I drag the year of order date on the filter and I make it equal to 2014. And then I show a list. Some other person will say, no, I don't want to see 2014. I want to visualize to 2011. This is interactive. This is what companies want to see. I want to see 2012. I want to see 2011. I want to see everything put together. See, that is important. See, I have a filter right here for the user to interact with it. Right, so I can now focus only on 2014. How do you achieve this? This is a visual process in SQL. How do you do that? It's a where clause. I don't want to see all. I just want to focus on the year 2014, the order year 2014. I go back. I see a column called order date. I want to zoom in only for 2014. How do you do that? You cannot put order date. This is exactly what I'm trying to highlight. You cannot put order date equal 2014. The order date has date and time. This quantity you see right here is not on the same structure as this quantity. You have to understand that dates have parts. This is the year part of the date. This is the month part of the date. This is the day part of the date. And this is the time component of the date. You cannot equate these several parts to this single part. Right, this right here does not go. You see, you get an empty. The system is trying to process what you're trying to do. Dates have parts. See, if this is projecting the year part of a date, you also have to transform this into the year part. And how do you do that in SQL? We use the year function. See, you have to put the year function, and then this is how that transformation is done. And the year function applied to this will retain this and dismiss every single one. That's exactly what the year function is doing. And now you're comparing the year on this side to the year on this side. This is now comparable. You see? And that's exactly what we've done right here. And if I execute, the system can process this. And you see, if I go to this output, 17,531 orders came in the year 2014. And every single one of these orders right here is bound to 2014. This is an important step in this analysis. See, I've addressed this. So it's through a where clause, a condition. In visualization, we call that a filter. And you can expose the filter to the end users. They can change this. See, if I switch to this in SQL, you have to go back and say, okay, now I'm looking at 2013 and execute changes, you see. So let's go back to 2014. I want to keep doing this so that I gradually build you towards the second model. Right, you start seeing the SQL behind the visuals. That's the goal, right? And then in this one, what are we looking at? For each month, show me the month. How do we, again, we are dealing with a full date. I just want to zoom into the month, right? I can go right here and use month. Right, I'm going to do two versions. I'm going to use month, and then I'll expose you to the two versions, and you choose which one is the best. So month on the order date. Again, I can just copy this, right? We are not interested in the full date. We just want to see the month. We are visualizing this for each month. You see the visual right here. It shows you the month of January. It shows you this total sales and total profit for that month. We go to February all the way to December. See, that's what we are looking at for the year 2014. That's exactly what we are trying to do right here. I can just alias this to be the order month. Let me just enclose this in square brackets. These are two keywords with a space in between. And then, of course, we're going to track those same quantities. I don't want to type this. I'm just going to extract. These are the same quantities we are tracking. I'm just going to put them right here. And I'll wait for a little bit. If you have a question, we can ask and address it. See, we are tracking those same quantities, the total sales and total profit. Now we're projecting it for each month in the year 2014. You see that? And again, we hit that same problem. If I run this, I get an error. You should be able to understand why this error. These are two columns that have been aggregated. This column has not been aggregated. So we have to take this logic and put it in a group by. So all orders that came in, for example, in the month of January, put them in one group. All orders that came in the month of February, put them in one group. You see, that's the same thing we do in this visual. These are the summations of profits and sales for the month of January. We go to the next month. So there's a grouping that is taking place. And that's why we're grouping by month. See, this is very important. If you ignore that aspect, you get an error. You must introduce that grouping into the picture. See? All right, you see now, compare this with what you see right here. This is very detailed. It's giving the actual names of the months. Right. And the advantage of this is that I can do an order by. See, I want it to go by the structure of the calendar. So let's order by month. This I can take an alias and put it in the order by. Right. And since these are numbers from the smallest to the biggest, will give me the calendar month. See, so I put ascending right here, smallest to biggest, I'll hit the target. See, this is January all the way to December. But you don't want to show numbers in the place of months to the report users. It's good to show actual names of the months. Right. So this is option 1 right here. And you make a choice between these two. Which one will you prefer? Right. This is option 1. And option 1, I'm using the month function to display the names of the months. In option 2, I'm going to transform this into option 2, and I'll be using the date name function. So I'll be using the date name function so that I can tell the system the part of the date I want to project the month. Right. So instead of using this approach, I will switch this into a date name function and then instruct the system, hey, give me there's something on my screen you might encounter. This is very, very frustrating. A lot of students have complained about this. See what is on my screen right here? Right. It makes things difficult if I want to type date name. See, this start stuff showing up. Right. Date name, it's really frustrating, especially when you want to delete. The cursor is not, it's not a single. I want to see the cursor is not on a single spot. It is zooming an entire spot. It's very frustrating when you want to delete things. So if you encounter this, it's easy to fix that. And this is the button right here. Just double OVR. It's set to override. Just double click on it. See, it should always be on INS, and that's where you have a blinking cursor. If you double click on it, for some reason when you're typing, I don't know, maybe I mess up with my keyboard, it goes to OVR. I don't know if you can see my screen right here on the task bar, just a little bit above this thing right here. So whenever you encounter that, this is when it's set to override OVR. Just double click on override and set it back to INS. It is better when you're typing on the editor and this option is set to INS. Right, so you have a single blinking cursor. You can control what to type and what to delete. But when it switches to override, you have this gray area. Sometimes frustrating. Right, so take note of that. That's how you fix that. It could be very frustrating. Right. So I want to go through date name and specify to the system here, I want to get the name of the month. So I'm going to put month. So instead of giving me 1, 2, 3, all the way to 12, I will be getting the actual name of the month. I have an error right here. I have to change this into this as this. So I want to get into what I am showing the month name. This is date name of what column. I will feed it the order date. Right. So from the order date, project the actual names of the months. right? So you see the structure changes. In a mon function is easy, just call mon. It's a direct extraction. To get the name of the month, you have to go to the date name function, tell the system you're looking at the month, and then this is the column from which you want to extract the month, and it should project me the actual name of the month. So if you've distorted this, take note, you also have to go and update the order by the group by position. So my grouping will now be based on this structure. This is very important, right? So each time you distort something on this, this is the non-aggregated column. The structure has changed. You have to update it, right? So that the non-aggregated column on your select list is in line with the grouping structure. You see, this is important. Now you can run this and see what you get. So instead of getting 1, 2, 3 all the way to 12, we're now getting the actual names of the month, just like what the visual is showing right here, right? And this is where things also become interesting. If you notice, when it comes to sorting now, since this right here is a string, order month is a string. So if you're ordering by a string, you're looking at what the alphabetical order of the month, no longer the calendar order of the month. In an alphabetical order, when you say order by order month ascending, it means you're ordering from A to Z. That's why April is showing first. This does not follow the calendar order of the month. If your manager tells you to show me the results in the order in which the months came in, I want to see January, February, March, just like that. So if you sort based on this logic, you're sorting on a string. And when you sort on a string, you're looking at the alphabetical order A to Z. And that's why you keep getting April, August, you see. See that this is not the calendar order of the month, right? So you should change this logic right here, sort on the month, using the month function, right? Order date, so that you're not looking at the month function is returning numbers for between 1 to 12. Now you can sort on numbers 1 to 12. Ascending will be from the smallest number to the largest, and the smallest being what? 1. That's equivalent to what? January. Second is 2, February. And when you include this, the system will always complain this, right? Because you've brought in a new logic which is not part of what you capture right here. So usually there's an easy way to fix this. You can just copy this logic right here and add it to the group by. Right. And now you can just run that. See, this is it. Visualization is really cool, but then writing the SQL, it needs a lot of practice. Right. So your goal is just to, stay focused and beat the SQL. And then you go now to the visualization and relax. And then you practice more visualization, more SQL. And that's how you get yourself prepared for those interviews. See them? You see what we've gone through to project what I just used a couple of minutes to build. See that? Because all the SQL is done behind the scene on the visualization. I'm just interacting with the interface, But then in this side, everything is left at your discretion. You control the process, right? See, and that's the outcome we get. This is option 2. This is more descriptive. I'm showing you the actual names of the months. See, and I'm also putting them in the order in which they occurred on the calendar. This one is cool. This one right here using the month function is also cool, but I get to show you just numbers corresponding to months. Right, this is not really cool from a visualization perspective. Right, and even if I go to Google and I show you maybe sales by month, let me see if I have any dashboard online. Sales by month dashboard. People will hardly use those numbers to depict months. If I go to images, let's see if I'm lucky to spot the dashboard that is showing us that information. And right on point right here. See this? Yes, this is an abbreviation, but at least you know what you're dealing with. See that? Right, so you hardly see those numbers, so you have to know that date name function pointing to month, Let me see if I can get some other different stuff. What do we have right here? Again, right here, we are tracking the same over different months. You see that? They didn't put where's their legend to see the colors. Yeah, I think the legend is somewhere right here. Right. So again, you see, we cannot be using numbers to display names of columns. Right. But then when it comes to sorting, it plays a vital role. You cannot sort by the date name function. You sort by the number side. So that ascending will mean one shows first, two, three, right? And that's how we made use of that concept right here. See? But then for the displacement of the names of the months, we use the date name function so that the end user gets to see the actual names of the months. But for the sorting, we use the month function, which rely on the numbers. So that when we put ascending, it means 1, 2, 3, all the way to 12. Right? You see that? All right, this is very important. This is cool. The visual is easy to build, but then the SQL behind that visual is the key. And that's why in every visualization interview, you cannot miss equation on SQL. Right? They will always ask you questions on SQL. Right? These are just different visualizations I'm showing you, and you see in each, this one is combining the month and the year. See? Okay, any question before we address the topics of today? The same thing on this one. This one is a little bit blurred. Right, so any question on this? So I will share this, everything we've done right here. So just attach it to this review document. Let me put this on the chat window. Right, this will be helpful to go back and review. Right, so just attach it to the bottom of this review document. I'm going to save this. And we should be ready now for the new functions of today. I'm just going to pause right here so you can copy that and add it. So I will go with option 2. It is really better from the standpoint of a report user. So I'm showing you the names of the months, not just numbers that represent the months. Right. Okay, I think we are set for the next. Please make sure when you add that, click on the save button to save the additional part at the bottom. Right. Okay, the next set of functions we're going to look at. So we're done with this segment. We go into the numeric functions. These ones, they're not very popular. I'm going to zoom in only on the popular ones. But some of these are not. Anyway, we're just going to have a conversation on it. So the next topic we're going to discuss is the numeric functions, and I have a list of them. So let's open this document, SQL Week 5, the 2 numeric functions, and we're just going to go over a couple of numeric functions. And one thing to remember when we talk about numeric functions, the column they're going to act on are columns that host numbers, integers, decimals, money, and stuff like that. Right? And one very popular one is this, the abs function, absolute. Some of you are familiar with this function. What is the absolute value of a given number? It just transforms the negative to positive. That's all. So it returns the absolute value of a number. Absolute is just the positive. So when I run this, I get that negative one. Right? If I want to see the positive, I use apps around that value. You see the transformation right here, it goes back to positive. If I run the two, this and this, you see the first one is just the way it occurs, nothing done on it. Second one is the transformation. So this is not a datetime function. This function is acting on numbers, right? And that's why we are treating this under numeric functions. Some people also refer to them as mathematical functions. Right, this is very important. Personally, I haven't used this in any of my projects at the company, but I just want you to know. Right, the next one, I'm just going to go over the functions, then we're going to take some questions at the bottom and do them. Ceiling, this is just a rounding up process. So it returns the smallest integer value that is greater than a number. This thing doesn't really make sense, but if I demonstrate it, you're going to understand it. So always look at it from a number line perspective, right? If I'm working on this number, I put the number on the number line, I put the nearest whole number from the bottom, and then I put the nearest whole number from the top. This is what the ceiling function is doing. Ceiling, from a reference point, ceiling means the upper one from the top. This is the number you're targeting. And if you expose the ceiling function to it, you're targeting this. The nearest whole number above your target. This is your target. This is what the function is being exposed to. The nearest whole number from the top of your target. So if you do this, you will never fail on these functions. You always know the right thing. So it's a round-up process, similar to a round-up process. For the ceiling, the opposite is the floor. The floor is more like a round down. So for the floor, this is what you're targeting. So always try to put this on a number line. You don't need to list all the values. Put this on a number line. Just declare the lowest whole number nearest to this from the bottom, and then do the one from the top. The ceiling will be targeting this one. So if I execute this right here, it gives me 2. That is the nearest whole number from above the target. Whole numbers don't have integers. Sorry, whole numbers are integers, they don't have any decimals. When we talk about integers, it's whole numbers, no decimals are allowed. So this function returns the nearest whole number from above. I think this definition makes more sense than this previous one, right? So returns the nearest whole number from above. Whole numbers are integers, no decimals are allowed. See, so this is always put it on a number line 1.4, put the one above. Whole number above 1.4 is 2. The whole number below 1.4 is 1. The ceiling function is looking at the above because it's a round-up process. Do the same for this one. Take 1.1, put it on the number line, just type it down 1.1. Above, you get 2. Below, you get 1. Now ask yourself, are we using the ceiling or the floor function? If you're using the ceiling function, you're targeting this as a result. And that's what you get for this one right there. Same thing for 1.9. This now I can change this to 1.9. That's my number line. Nearest number above 1.1 is 2. Nearest number below 1.1 is 1. Since I'm using the ceiling function, I'm looking at the above one. So if I run this, I get 2. It has nothing to do with significance. And somebody might say, why don't you just try? I think I had this question from a student. Why don't you try 1.5? Since 5 is above that threshold, it should round it up to 2. No, that's not how it functions. Right, even if it's 1.4, that's why I'm showing 1.4, 1.1. It has nothing to do with the significance. Right, you see that? It's either the rounding up or rounding down. Right, the ceiling is rounding up. It has nothing to do with accessing this and seeing if it's above 5 or not. See that? So all of this, right, understand that process. Now for the opposite is the floor. See, the opposite is the floor. And floor, of course, is a round down process. So for example, 1.4, this is 1.4 on the number line. The whole number below it is 1. So this result to 1. This will also result to 1. This will also result to 1. Right, that's the flaw. See that? Yeah, this is very important. Always plug it on a number line to understand this. I've used a couple of this function at a very strict job requirement. This has nothing to do with the significance. There's a roundup function we're going to talk about, a rounding function, which is different from this is it right here. Round in the round function, you have to specify round this to 5 decimal places, round this to 3 decimal places, 2 decimal places. Then you can use this one. Right. But then the concept of the ceiling and the floor is about integers, whole numbers. It involves no decimals at the final target. You can pass a decimal to it, but the final outcome will not be a decimal. It's an integer. You will have to know the difference. Right. For the running process, I can give you numerical monetary values are always rounded to the next to 2 decimal places. Yes, you can use the round function, right? And you specify the number of decimal places to round that. I think that's the next function we're going to study, right? So usually when I explain this part, some students always think about the rounding process. The rounding process, the final answer is a decimal. But the floor and the ceiling, the final answer is an integer. You get the ceiling part if you're rounding up, the floor part if you're rounding down. It's completely different from the round function. Now, this is a round function right here. Round this number to 3 decimal places. See? Now, let's project this number to 3 decimal places. I've never been a fan of this round function. It's always going to mess up things. It stops at exactly 3 decimal places, and then everything after it outputs zeros. Now, if you do target 1, 2, 3, these 3 decimal places, stop right here. Assess this is more than 5. Add this, promote this to a 6. Yes, it does that. This is 6. But then it transform everything after that into zeros. See that? And when it comes to formatting in dashboard, your manager will be strict on that. Right, format things. See this formatting right here. This is format to 2 decimal places. Right. If you use a round function, it's going to mess things. There are other numbers after this. We don't want to see those zeros. Just hit the target and any other thing, dismiss it. So we should be targeting something like this as an answer. Right, you see that? Just stop right there and deliver that. You see, but then the round function does extra. It will now stop there and just everything becomes a 0. I don't want to see those zeros. See, if you're dealing with a strict manager when it comes to formatting on a dashboard, that could be a problem. And I have a solution for that. That's when I can propose you the format function. It will never fail you. Right, I'm not a fan of the round function. It always fails when you need it. Right, because of those extra zeros it gives, you see. Right, this is not rounding to 3 decimal places. Right, this is what you should get. This means the zeros. So compare this and this. This is a true outcome rounding to 3 decimal places. 1, 2, 3. Stop right there. Access this number. 6 is above 5. Promote this to a 6. And then return this part. And that's it. And stop right there. Don't give us extra zeros. You see? Now let's try that on the format. Format function. Let's take this right here. That's a number we want to format. Put it right here. Just a moment. Let me call that number. Let me select. Let me just project this. Nothing has been done on this number. I'm just printing it the way it occurs right there. Right. Now format this into 3 decimal places. Interesting. Just wrap your format function around it. See that? Put a comma right here and then use this. Last time we talked about currency. This is not a currency. We want this is a number. So N for number, C for currency. Just stay with me on this. And then the 3 now, 3 decimal places. See that? This is really easy. So if you put C, it's currency. If you put N, it's a number. You're formatting this number and then render it to 3 decimal places. And this is it. And you see how it does a nice job, which is exactly what we expected, this thing. Not this funny stuff right here. Right. And of course, you see this in Power BI. It's just visualization. It's just a click of a button, and you see the formatting option right here. You go to the number side. I want to format this as a number, and you can then use this button to control the number of decimal places. And that's what we do in the format function. Right. Format this as a number. N means number. And then this is the number of decimal places you want. See, it's really easy. Right. That's it. If you're dealing with a table, you're going to replace this number with the column. Right. So this is always delivers. See this funny stuff right here. Run this one. See, I want to project this to 3 decimal places. It goes 1, 2, 3. Right. This is not up to 5, so I'm going to stick with what 1.345. This number stays the same. This is where significance comes into the picture. Ceiling and floor has no business with significance. It's all about integer, nearest whole number from above in the case of a ceiling, or nearest whole number from below in the case of a floor. But when it comes to rounding up, the significance concept comes in. I think we saw this in primary school, right? And then formatting is just the best. N for number, C for currency, and this tells you the number of decimal places. It's really easy to remember this. It mimics the Power BI concept, because in Power BI, if numbers will be formatted through the format menu, like what I showed you right here, you have to click on what you want to format. The thing, you right click, you see the option format, and you go format it. See, this is a format menu right here. See that? So this actually does the job. Right, 3 decimal places, you get 3. If I change this to what? 2 decimal place, you get 2. See, if I change this to 1 decimal place, you get 1. See, the default, let me see if you just put that, what is going to be the default? The default is 2 decimal places, and that's what most people format things to, 2 decimal places. So without doing anything, the default is, if you change this to C, you're not looking at the currency. It's going to find a way to project this as a currency. Default US dollars, 2 decimal places. See, but then this is a number. We're formatting this as a number, 3 decimal places, right? So like I said, I'm not a fan of the round function. It always fails you when you need it, right? All this explanation is not going to make any sense if, let's do some examples. So let's go back to this AdventureWorks 2022, and let's just write a query using this table. Okay. Let me see. Let's just remind ourselves on how that table looks like. It's been a while we've not addressed this kind of questions. I'm just going to take everything out. This is a table we have. Run it. That displays the subtotal rounded to 2 decimal places. Where is the subtotal? I go to the right hand side. We have total due. It's a subtotal right here. So we want to display, you see the numbers are more than 2 decimal places. We want to display 2 decimal places. Right? And these are the columns you should include in the output. So we are talking about order ID. This is the original column, and then this is the part that we round the column to 2 decimal places. You see, in the case of a table, you're putting a column. See, it's unlike the arbitrary stuff we're doing right here. It's just an arbitrary number, non-table based queries. In the context of a table based query, you want to change the expression and make sure you're pointing to a column. So we want to round all the values in the subtotal column to 2 decimal places. And I'm showing you this so that you can compare. This is the original, and that is the rounded version. Let's run this so you can see. This is the original, this is the rounded version. Yes, this one delivers actually. So we are hitting our 2 decimal places. Yeah, it's actually doing a good job. See that? Yes, it's doing a good job. Right. And if you want to add the other formatting to this, please just add this line. Let's format subtotal to 2 decimal places. Just copy this column. Control C, Control V, put a comma, and then this is a number, so you put it as a string. And then just specify 2. The default even is 2. So even if you remove this 2, the default is 2. So run this and then compare the two. See, they're basically hitting the same. But this one is adding 1,000 separator to it, which will help you to read. Let me show you the difference. Formatting does something unique. This is what you get from the rounding, right? Compare this. This is what you get from the formatting. So formatting puts 1,000 separator. See that? So you can start reading this easily. This is 28,000. It helps you with the reading. This right here, you have to, now 28,000. So formatting as a number, it just preps the environment for you to read it easily. Right? You can just start reading this without, taking a break and see, are you dealing with million or thousand? Oh yeah, this is thousand. Yeah, but this tells you right away, this is 1,000 stuff, and you can just read directly. So there's a difference. This is extra formatting because it's a format function, right? So I just need to expose you to this, right? So we're lucky that the subtotal for the round function delivered, it did not mess up this for us. It stayed on point and gave us exactly what we requested. Now let's try to push it to 3 and see if it's going to survive 3. Run this. Yes, it's doing a good job. It's giving us the 3 days. Yeah. Okay, so that's fine. Right. Now I want to show you the round and the floor and the ceiling on the same output. And the original column is the subtotal. We're going to project subtotal, rounding it to 2 decimal place. Project subtotal using the floor. Project subtotal using the ceiling. And this is a good way to actually see what these 3 functions are doing. All right, this is the original column. Now subtotal 2 decimal places. Yes, it works. This is a rounding to 2 decimal place. Now what is a floor function applied to this value? This is a floor. And if you notice, the data type is impacting this process. The data type is what? Money. If you put your cursor on a column, it tells you it's a column. The name of the column is subtotal. This is money, not null. So it preserves that money structure, right? That's why it's rendering this sense part. If you're dealing with a decimal integer, it will just convert it to an integer. So the idea of a nearest whole number, it doesn't apply to this because of the data type is interfering. I will show you a function today which will enable us to change data types. We're going to get to that. This is going to be the cast and the convert, this one. Right. Okay. Let's take one more question and then we're going to go on a break. Anyway, let's just finish this part and then we can go on a break. Right. This function I'm taking you to is not popular. Things like the square root, the power, and this is basically an investigation. Let's just go over those, but I've not done any project with this or this. But you understand that basic arithmetic, take 2 and raise it to the power 5. That's what the power function is doing. And this is the expanded version of that. So just to show you and understand that, hey, there's a function called power, which you can take a certain value or a certain column and raise it to a particular power. See, we're all familiar with this from basic arithmetic. See that? And that's the same concept with the square root. This is a square root. You know what the square root means? Square root, this is it. Right, but have not used this in companies to solve business problems. Right, so I just mentioned that, but I'm not going to go any further on that. This and this are not very popularly used. I've seen some applications on this. This is just like an investigative function. We saw this for dates. We have the isDate function, which is investigative. It returns 1 if it's a date, and then 0 if it's not a date. Same thing with numbers. We use the isNumeric function to investigate. If the value you're seeing is a number, it's going to give you 1. If not, it gives you 0. All right. If you look at this, it's just a textbook example. Write a query that calculates the square root of a given column. This is not what business goal are you trying to achieve if you take the sales order ID and find a square root out of it. It's just textbook example. You're not going to see this in the business. I'm going to skip that. So let's look at the SQL interview question on numeric function. This is it right here. It's back to that website. See, this website right here. I will always try to incorporate this website in the training. It's so powerful, especially on those interview questions. Oops, I want to share that on the chat window. So that question, I think that should be the Amazon one. Let me see if I have a link that takes you specifically to that question. So this is the average review ratings, the Amazon. But anyway, I have the question right here. I just wanted to show you. Let's just go Amazon average review rating. Yes, this one. Okay, this is the actual link. Please go for the second link. This link, I'm just going to update this, remove this. This just takes you to the main website. But this is the actual link to that question. Average review rating. See that? So let me just read the question right here. We are dealing with the Amazon database. We're looking at the reviews table. Yes, you have that information. Amazon database, you can connect. Do a select style from the reviews table. You have it right here. So this, we have the review ID. So basically, when you purchase an item on Amazon, after using the item for a while, they're going to send you a link to do a review on the item. Most Americans are crazy on reviews. They don't buy any product without reading the reviews, what other people said about the products. So reviewing is very, very important, you see. So the reviewer ID is the person who did review. User ID, the submit date, this is the date the review was submitted, this is the product the review was done on, and these are the number of stars given. I think it ranges from, I think, 5 stars, I think it's the maximum. I go to Amazon product review, and there are actually jobs that are tied to that process. Let me just go to images. Yeah, this is what I'm talking. 1, 2, 3, 4, 5. So usually, yeah, these are review rating. This is how it looks like. So these are customer reviews. They write a review, and then first of all give the number of stars they want to give, write what make them like the product or hate the product, and you can see the general average review of the 5 stars. Those, you see, breakout in percentage. This is actually statistical analysis, data analysis, breakdown on this. So that's a similar kind of thing you want to do, right? If you read this question now, you're going to understand what they're trying to target. See, so given the reviews table, write the query to retrieve the average star rating for each product. So show me each product and give me the average star rating. Now group by month. See, so each product in each month. This is very important. The output should display a month as numerical value. See that it's not going to be like the system we did right here. This is month as a string through the date name function. They just wanted to keep it simple. Month as numeric. See, so we're just going to use the month function to do that. So you're going to show the month, show the product ID, and then give us the average star review. See, then round it to what? 2 decimal places. Sort the output by first the month and then by product ID. See that? So let me just go back to this and we'll project this. The question is right here in front of us. So for each month, how are you going to calculate the month? We are using the month is a date function. So the only date column we have on this table is submit date. So we're going to be targeting submit date and extracting just the month. See, these are the different parts of that date. We're interested in only the month. So we use the month function, and we're told that we should project month as numeric value. Spot on. The month function returns a number. So we are good on that. This is a submit month. Right. Then also show me the product ID. If you read the question carefully on the output should include month. That's the first column right here. month, and we call it the submit month. It's a new column we've created. Next column, the product ID. Yes, it's something we can pull directly from the table. That's a product ID. Nothing will be added to it. Product ID. And next, the average star rating. We have a stars column. See, the rating of the product. I think I showed you an image right here. See, this is, it goes from 1, 2, 3, 4, 5. 5 is the highest star rating for a product, and these are the star rating. See, so give me the average. See, average star rating. We have a ratings, a stars column. We're going to transform that into an average. See, now these are the 3 columns we are targeting. 1, 2, 3. Of these 3 columns, one has been aggregated. The stars column has been aggregated, average. So what does that imply? It means that this and this should go into the group by. That's non-negotiable. See, if I run this on like this, I'll fail that. You see. So you have to understand why my group by has month. That logic, you cannot group by an alias. See, it has a logic, this, and the product ID, which is this one. Please take note, if I use the alias, you cannot group by an alias. I will come back to that explanation. I keep promising, but I want us to build enough ground so that you can understand that area. If I throw in the alias right here, it is going to complain immediately. But that's the same column I'm using in the group, in the order by. You can order by an alias column, but you cannot group by. In fact, you should just know only where you can use an alias. An alias is only allowed in the order by. Any other thing is not going to allow it. I don't want to explain the two sides. It gets confusing to students. Only tell them what you cannot do. Or sorry, what you can do. Aliases are only allowed on the order by. That's the only thing you have to know. Now, the next part of that question is why. I'll explain that later on. See, I want to do it step by step. So you should never take a column alias and put it anywhere other than the order by. I hope that makes sense. Then next, subsequently, we're going to talk about the explanation to that. All right, so this is it. Now, if I run this, this is what we're getting. So for each month and each product ID, I'm showing you the rating they receive. And that column called stars, what data type is integer, right? Integers, you will never have decimals out of integers, even if it should occur. Let me show you an example. You might think that SQL does not know basic division. Take 5 divided by 2. You will be surprised this is 2. Why? Because 5 is an integer, it's a whole number. 2 is a whole number. You cannot get oranges out of apples, or vice versa. You see, the system sticks to the whole number concept. Right. But the moment I do a small modification on this, right, now you see it's going to mimic. You see that? So data types are very important. This averaging is based on a column that is strictly integer. Right. Under normal circumstances, you should be having some decimals if they are, since you're averaging, but it's just flacking, whole numbers out of that process. Right. And then this is now the idea of rounding the average star rating to 2 decimal places. An average star rating rounded to 2 decimal places. See? So you now go back to the averaging, this is it. And you want to round up the average calculation toward 2 decimal places. So I do them separately so that you see the flow. Now if I run this part, like I said, we are still in the integer framework. It doesn't still follow through. And that's why there's a important conversation we're going to get on changing data types using the cast function or the convert. Sometimes you're dealing with a column that is not in the right data type to favor your calculation. You cannot just sit and complain. SQL Server gives you the ability to change data types of columns within your calculation, not from the original database. See? So we are trying to round up it. Things are still static. It's just the data type, right? This is very important. This you can relate this from this simple example. You will not have your 2.5 that you expect to get right here, because the numerator is a whole number, denominator is a whole number, final answer will be a whole number. Right, this is very important. So it's a data type that is conflicting that calculation. Right. Let me copy this and let's use the formatting. So I'm going to change this to format. So using the format function, let's see if it's going to help. The data type has not changed. So in the formatting, you have to change this into format. All right, so we're going to format the average of that into a number. So I'm going to put n right here, 2 decimal places. And let's go ahead and run this. Yeah, so format, try to force something out of that. Yeah, so we have this. But these are just placeholders. The actual decimals were kicked out. Right, but if the data type favor that calculation, you see actual decimals, not just adding the zeros to just make it up. See, right. So I'll come back to this question when we do the data type functions. There's cast and there's convert. Right. Okay, so this is it right here. In all these interview questions you see right here, you can always look at the description of the question. You can look at the solution. And this is what I mentioned last time. When you're reading the solutions on this website, you have to bear in mind that this is built through PostgreSQL. This is not how we extract month from a given date. So if you copy this query and you just take it to your management studio and you try to execute it, you're going to have serious errors. Right. See this, you have actually the Amazon database, you have the table reviews, yes, you have everything, you have execute, you have an error. Why? Because the system does double click on the error line, you see, it doesn't give you, you see, the system does not recognize this process you're trying to do right here. How do we extract month from a date? We use the month function. There's nothing like extract that. This is a PostgreSQL way of doing this, which is not recognized in SQL Server Management Studio. So extracting a month from a given date is through the month function and typing the column like this. This is now the appropriate way to do that. You see, SQL Server now recognizes this. Right. So we are extracting the month from the submit date, and this is the alias column name. Alias. We are projecting the product ID. Yes. Average is recognized in both Postgres and T-SQL, and then the round function is also recognized. Right. And then for the group by, we have to group by these two columns right here. So I have to copy the same logic, knock this one off. This is not what SQL recognizes. And then this, see, now you've transformed this query and you've made it T-SQL friendly. See, now you see it works. You see, right? This is very important. If your manager wanted to see the actual names of the month and not just the numeric version, you will have to transform this query. You have to go through the date name function, right? And then tell the system that you want to project the name of the month, and that function is called date name. I want to project the name of the month, and you should use this column for that calculation. And whatever I do on this, it will also impact the group by. A lot of students forget, if you go to this and try to execute, you get an error because you've distorted the grouping structure, you brought in something different. And from the previous analysis, we've also seen that this part is also needed. Let me just paste this so that you can see. Okay, now let's execute. Yes, see, now this works. But this is not what the question wanted. The question wanted you to give the month as numeric value. Display month as a numeric value. You see, so the numbers are okay. Right. So this the solution is given right here, but unfortunately, this date functions don't tie with what SQL Server is, you know, advocates for. But every other thing falls in place. And there's also a discussion from students also propose solutions. Right, but please remember this. This is built in PostgreSQL. You're going to see some things that are not recognized in Management Studio. See? Okay, at this point, we can take a break. But before we go for the break, any question? So when we come back from the break, we're going to go to string functions. Yes, I had a question. I had something to talk about on the East Numeric. It's an investigate. Let me see if I have it. So East Numeric is a function that will help you in investigating if the values in a given column are numbers. So this is an investigative function. If yes, so if what you're investigating is number, numeric, you have to always look at this from a question mark perspective. If yes, this function returns 1. And if no, this function returns a 0. If no, this function returns a 0. So this is investigative, right? And a typical example I want to show you is this. Let's use. There's one table in this database, AdventureWorks, I think this one, which gives you the size of products. Sometimes the sizes are given to you as letters, small, medium, large, extra large, or sometimes the size are given as numbers, maybe size 10, size 50, Right. So this is the point I want to make right here. If I do a select star, let me see if I can target that table and just discuss briefly on that. It's going to be these products, I think. So you target a product table and let's focus on the size column and you're going to see what I'm talking about. Size sometimes is reported as a number, sometimes it's reported as a letter, right? So your manager wants to see only products in which the size is reported as a number. Let me first of all do something basic. I'm just going to show you, I don't want to show you everything, but just give you a list of columns we can rely on. Let's get the product ID, name of the product. Let's get the color of the product. Now, finally, let's get the size of the product, right? Yes, let me just limit it to that, right? So if I add a new column right here, which does that investigation, the is numeric, I'm going to call this function called is numeric, and I apply the size column to it. I want you to see this, right? Sometimes when the explanation is done, you actually have to see it to believe it, see, and understand how it works. So this is what we're doing. We're going to that size column, and we're going to be investigating the individual values. If it is a number, if it's a number, we get 1. This is where that concept comes. If yes, we get 1. If no, we get 0. So this function is going to create a new column with values 1, 0, 1, 0, 1, 0 throughout. You see that this is a number, 58 is a number. You see the response for the investigation is 1. 1 means what? Yes. This is a number. The response of the investigation is 1. 1 means yes. It meets something that's unknown. You see, of course, unknown is not a number, so we just safely no, 0. This is not a number. This is missing stuff. So it's either binary. It's a binary outcome, either 1 or 0. There's no in between. You see that this is a letter. This is 0. It's numeric. Always remember, it's investigative. It's a question mark. is numeric question mark. If yes, get a 1. If no, you get a 0. It's the same thing with the date function is date. You're investigating if something is a date. I think I demonstrated this yesterday. For the benefit of those who were absent yesterday, I can give you a date. All right. If I'm just checking the February calendar, and this month has 29 days. So what does that mean? It means that there is nothing like February 30th. There's no date that exists like this. This is an invalid date. Right? See that? If you store a column as date and you try to insert this value in that column, you're gonna get an error. But then the system will print it out for you. But then you can now use the isDate column, the isDate function to investigate. Is this a date? Use the isDate. And of course, since it's an investigative function, it will give you 1 or 0, yes or no. It's always a question mark. Is this a date? You get 0, it is not a date. You get 1, it is a date. So the current month has 29 days. If I change this to 29, it's going to recognize this. This is a valid date on the calendar for February of 2024. If I run this, I get 1. It recognizes that yes, this is a valid date. If you go to the calendar, you'll see this date. So this is for date, an investigative function for date. Numbers also have their copy, which is the isNumeric. The investigative function for numbers is the isNumeric. Right, so this is what I'm trying to do right here. So how will you put this in the code to answer this question from your manager? Numeric size products, only products that have numbers on their size. This is how you're going to code this. You're going to put a where clause. And this is the investigation right here. If this investigation returns 1, that's a number. If the investigation returns 0, that's not a number. So this is how you're going to address that. This expression will be true only for those products where the size is a number. That's what I'm doing right here. Is numeric size equal 1? And if I execute this, I'm answering that question. You see, knowing a function is one thing, knowing how to use it in problem solving is another. So I'm now showing my manager only those products where the size is listed as a number, right? And if I want to do the opposite, products where the size list is not a number, non-numeric size products, yes, I just have to change this to 0, right? Or I make it different from 1, anyhow you want to do it. You see, but then you understand. Yes. Now if you go to size, see, no number is listed right here for the size. So this is an important investigative function you have to know, right? I've used this isDate. I was exposed to a database in a table and there was wrong dates that were inputted. This is just typing error. If you look at something like that, you can be dealing with the data set you're analyzing and somebody inputs this kind of date. And I was using the datediff function and the system was giving me an error. Right. Let me show you typically this date, right? I want to calculate the number of days between 1st of February and this date. All right. And I started using the datediff function. See? All right. And let's see what we get. So I'm using the datediff function. I want to calculate this in days. So I put give me the number of days between this date right here and this other one. All right. I'm going to take this all the way to the first. Right, you see, let me just put a 01 right here, you see, all the way to this. But take note, this is not a date, this is not a valid date. Let's see what this function will do. 1 is a valid date, this is a valid date. So I'm taking all the way to the 1st of February 2024. I want to calculate the number of days between this date and this one, but this right here is what it did. So let's see what the date diff function will do. It gives us an error. And now, as a data analyst, you are dealing with the column with millions of rows. You don't know why this is giving an error. So you're gonna use the isDate function on the column that is hosting these values, and also the isDate function on the column that is hosting these values to test this. The date function has spotted something wrong. See, one of these is not a date. See, and if you're dealing with a table, this will be a column, this will be another column. You have to use the isDate function separately on this column and separately on this column to know which one is not a date. See that? This is very, very important. No matter what you do, you will not be able to escape this, because the date diff function is a date time function. It works only on dates, valid dates. See, date and time function is treated, is right here, date diff. You cannot escape this. Right, so now if I transform this, I understand, okay, this should have 29 days. Now I've adjusted this. You see what the date diff function will do? It gives me the correct, but then this one, you're going to waste your time right here. You see? So this is what you will normally do from the implementation of the date diff, the isDate function. You take this and investigate it. Which one am I making an error on it? Now this is the investigation you're going to do. Select, you use isDate. If this is coming from a column, copy this column and put right here. Put the table reference in the from, and then run it. See, yes, it approved this. This is a date. So the problem is not this one. Okay. And then do the same investigation on the other side. All right. I'm going to copy this one and do the investigation. Now you can confidently tell your manager, hey, this is there's an invalid value in the date column. And this is it. But then there's something they call data type. If you capture data type correctly, then you will not even have this error in the first place. So every column, I'm keeping this for the last phase of the project. We're going to build a database from scratch so that you can start seeing the concept. When you're building a table, how do you specify the data type? Every column has a data type. Let me show you a simple example. I go to the table. I go to the student table, right click. I go to edit. Or not even edit, I just look at the design of that table. This is how that table was built behind the scene. Like, this is something I'm showing you for the very first time. Every column has a name, has a data type. If you look at date of birth, it's stored as date. You cannot insert any value into the date of birth column which is not a date. Some companies store dates as strings, VACA, like how you store your first name, last name. And those ones are dangerous because all those invalid dates can now fit in because they are strings. See that? You have to understand that this is right here is a string. This right here is valid as a string. It's a string, but it is not a date. So instead of storing it as date, if you store it as a string, it will enter the column. That value will get in. And then you will now discover it as a data analyst during your analysis. Like how we did discover this one. We're trying to use the date diff function to calculate the number of days between two dates. And when we execute it, we get an error. But then you look at your query, everything is fine. This is where you start having confidence in yourself. You might think, oh, I've done something wrong on this. Why is this giving an error? Right? It's because this is not a date. Now you do this simple investigation. Test this. That's the investigation right there. It's a date. Yes. Test this one. It's a date. No. Okay, now that's the error. You see that? So these investigative functions are very helpful in troubleshooting in data exploration. Companies will be very happy when you start correct their things, identify errors in the database and draw alarm on it, raise an alarm on it, you see. Right, so this is very important. Take note of those two functions. For the date side, we have the isDate to investigate. For the numeric side, we have the isNumeric investigation, you see. Okay, I think we are due for a break. Let's take a 15 minutes break. Right. So when you're back from the break, we now start looking at those string functions. Right, these are string functions, so we're getting to columns that are hosting strings. We've seen columns that are hosting numbers, that's the numeric functions, columns that are hosting dates. Now we're going to see strings. Okay, so let's take a 15 minutes break and we're going to continue after the break. So after the break, we're going to start with questions if you have any before we go into the string functions. Okay, guys, are we back?
Yep.
Okay, so yes, so now we're going to look at this string functions. Let's begin with the common one, the concat. All right. So concat is just to join things together. I once used this terminology. Let me just try to show you the context in which this was used previously. So remember how we did 1 plus 1, 2, 3 plus 1, 2, 3, and we joined those two into a single string. You're going to have two options depending on how you set up the environment. So 1, 2, 3, this is going to be interpreted as numbers, 1, 2, 3, and this would mean summation. You're joining the two together. Uh, did I run something different? Okay, yeah. So this is going to be mean summation. If I copy the same stuff right here and I put it in a different environment, I transform this into a string. I'm changing the data type. This is going to mean a concatenation process. And that process is coming from this function concat. So concat means to pull things together and then you preserve their integrity. You see, just join them, but maintain each other structure. See, this is built from the concept of concat. All right. So the plus sign right here is playing the concatenation role. But the plus sign right here is playing an addition role. Now, if I want to make this more professional in the way it's going to look, I can call the concat function and say, hey, can you join these two strings, 1, 2, 3, as a string? In this case, I don't need the plus sign because the concat function is doing that role. I just need now to put a comma and declare the next one. So that's how the concat function works. You want to put things together, combine first and last name together. We are going to move away from the plus. We're going to use the concat function. See, and I can keep adding. I can add another expression. You see, it's going to fuse them together. That's the process of concatenation. So this time around, we don't need a plus sign. The plus sign is being played by the concat function. You see that? So this is just a gentle introduction to that. And this just triggers something. If you remember, let me just switch to academia. And then we're going to be combining first and last names of students. Previously, we're using that plus sign, but you're going to graduate from that and you start relying on the concat function. Whenever you're asked to pull things together, different strings, different components, just comma separate them and then you're going to link them up. You see that? Yeah, this is very, very interesting. Let me connect to the student table. I'm not sure if this is, let me just check one moment. So on the student table, yes, it's DBO. So let's do DBO the student. I don't know why. Okay, let me switch to academia. Now we can access the DBO schema, pull up the student table. Just write me a query that will combine the first and the last name of students into one column. That's a concatenation process, right? So professionally, this is what you're going to be using moving forward. We are done with the idea of putting a plus sign right here, transforming that. We're not going to be doing that. Right, so you're just going to rely on the concat function. So whenever you faced with a requirement to combine things, strings and stuff like that, just rely on your concat function. Put the first one right there, put a comma, put the second one right there, you see, and the system will figure out a way to link those two together. So we are done doing the plus sign. This is it. And then we still have that same issue we had with the plus sign where the two are fused together, no space. Right, how do you add a space? Just go in between this and the symbol for the space remains the same. So we now have three expressions. This is column driven. This is just static space and this. The system is going to concat these three expressions together. right? We now have the first name, space, and the last name. So we are done with the primitive idea of using plus. In a primitive way, there's no concat function. Let me just copy this and transform it and show you what we used to do previously. You just make sure we put the plus sign right here. Take the first name, join it, concat it with a space, and continue the process to the last name. This is what we used to do, right? But thanks to the presence of the concat function, we are done with this, right? So whenever you're given a task to combine things, you just rely on the concat function, right? There's a series of expressions. If you look at, if I put right here, built-in function, concat, put an expression, put a comma, put another expression, put a comma, and so on. You see the ellipse, the three dots right there. Right, as number of expressions you can fuse together. That's it. Very simple function, and it's very powerful as well. Right, so that's the concat function. If I go back to this now, you'll be able to see. I think I have to close this, and let's open the documentation for string functions. These are numeric functions. Shut it down and then go back to the lecture materials. Let's open this one, string functions, right here. Open. Yeah, so string functions, there's a W3 schools reference on this. I'm switching back to academia. And the string functions, okay, I will begin with those conversions. I'm going to skip this for now. We're going to come back to that. Let's do this and this. I think on the list, we're looking at that. Data type conversion functions. To change from one data type to another, right? Look at this right here. This is decimal, right? 25.65, execute, it stays intact right there. The moment I use a function called cast, I want to cast this as an integer. Remember, I told you integers are what? Whole numbers. So we're not going to be getting 25.65. We're going to be getting a whole number out of that, an integer, 25. The 0.65 reference has been dropped because that's integers are what? Whole numbers. So sometimes you have data in front of you, you want to analyze it, but it is not in the format or the data type you prefer it to be. You don't need to complain. There are two functions for that process. Most people prefer this one is common and straightforward. There's this and there's this. Convert and concast. Those are the two functions that you can use to change data types of any column, right? To put it in a format that favors your calculation or whatever calculation or logic you want to implement. Right, this is very important. Let me go back to that example we discussed previously where I had this expression right here, 5, select 5 divided by, it's a simple one, 5 divided by 2. See that? And I execute this. It's supposed to give me 2.5, but then you understand that it's just simply respecting the data type. The numerator is integer, denominator is integer. The outcome will be an integer. That's what SQL tries to do. It sticks to the data type. See that? So if this doesn't favor you, you might say, okay, you know what? I want to do some transformation. I'm going to change the data type of the numerator, that's 5. I'm going to change it as a float or decimal, float and decimal, you see. Right, and then even if I don't convert the one below, at least I've changed one of them, you see. Now if I run this, see how the outcome is going to be different. You see that? Floats, decimals, they do allow those decimals to come in. But then when you're in this context, it doesn't work. Right? And I will now take you back to that example on average stars, and we're going to convert the stars column into a float. So that when we do those averages, you see decimals showing up. See? So this is very powerful for a data analyst when you're trying to perform a calculation which the columns you're dealing with does not support the calculation you want to do. You can transform the data type without complaining to the project owners and stuff like that. And the changing of the data type, it's only at the level of the query. It does not go and change it at the level of the table. This is very important. So you're just doing this to favor your calculation, and then you get done with it and move to the next project. So there are two functions. We have the cast function and the convert. So cast is simple. cast this as an integer. And when I execute it, you see that number is not going to show as a decimal anymore. You see, integers are whole numbers, right? So let me show you another example. Let's go back to this right here. I have first name, last name, student ID, 3 columns, simple. I project those. Just follow through this requirement. I want you to combine first and last name. As we're going to study the concat function, we're going to move away from this process. But let's just follow through with this. Right, this and this have been joined together with the space. This is what you get. Now, I want you to add student ID to that process. So join first name with a space, last name with a space, and student ID. See what we have now. We run this, and immediately we get an error. And as a data analyst, when you have an error like this, you have to back up a little bit. Go to where it worked. These two work. So what is the problem? This one you brought in. So the error should be around this area, right? Because previously you had these two and they work. See, and when you have errors like this, always check the data type. When you have any error that talks about conversion failed, conversion is always tied to data types. So let's inspect the data type. This is a string. This is a string. It's a number. That's a problem right there. You cannot fuse this, right? These two work together because they are of the same data type, similar data type, strings. I'm now bringing student ID as an integer, right? So the system is not allowing me to fuse those together. See? And you can just go test it out on some random stuff. Let's take this 1 to 3 plus the string version of 1 to 3 and then test that and see if it's going to work. See, this one works. Let me transform it into a much more severe case. Yes, right. Let's run this. See, these are now extreme scenarios. We have now a conversion error. This is string. This is integer. You cannot fuse the two. And that's how this error was generated. These data types are similar. The system has no issue fusing them together into one column. This and this are good, but this is completely different. This is a typical reflection. We have an integer, you're trying to join it with a string. The system is asking you now, if you join these two together, what will be the data type? Every expression needs to be classified on a data type. So if you're forcing these two together, what will be the combined outcome? That's what the system is trying to figure out, and it's not working. Right. So you have this error right here. See? And the error is originating from this student ID. It's an integer. Meanwhile, this and this are strings. Right. This is very, very important. Right. So see what we're gonna do. We're gonna target this as the integer. We're gonna transform it as a string varchar, so that it's in the same data type with this. See, this one is varchar, that's string. This is varchar, that's string. So we're gonna transform student ID as varchar, so that we have 3 strings, 1, 2, 3, and we can now join them together. Execute. You see that they now go together. But without converting it, you have an error. You see that this is very, very important. But then the good news is that when you use the concat function, you don't need to do that conversion. So let me just, I'll go to get to that gradually. This right here again is just to demonstrate that same knowledge. These are the same data type, so addition will be the outcome right here. These two will be added together. Right. I think I'm going to put this other version, which we just saw. Right. We saw this version. Right. The system still managed to force an addition. If you notice, we still sum it up. Although 1 is integer, this is also a string, yeah, but then it has the physical appearance of a number. So the system just went ahead and did the conversion for us, even though it was not requested, but it did it, you see. Right. But then in this other scenario we saw right here, it was just way off. These are extreme cases, right? And you definitely had an error on this one. This is strictly a number. This is a string. How are you going to fuse that together? Right. See that? But then see the power of the concat function. Let's now repeat this process in a professional way. This is the crude method we used previously. This is that beautiful approach of the concat function. Take the first name right there, concat it with a space, concat it with the last name. So we're going to have three expressions to fuse them together. This is concatenation, and it's built from this function called concat. It's a short form of concatenation. So take this, fuse it with this, and then fuse it with this, and project all of them in one column. That's it right there. See that? Nicely done. Now, see the extension. What if we bring in the student ID? Student ID is an integer. This is a string, integer. The concat function will not complain. It will understand that, hey, student ID is not a string. It will go ahead and convert it for us. But if you notice, when we tried doing this with the plus sign, we had an error right here. See that the plus sign does not understand that, hey, this needs to be converted. It leaves that for us to do. So we now relied on the cast function, converted it, and then now we could execute that. So three strings joined together gives the final outcome a string. See, so there's no confusion on that process. So that's the beauty of the concat function. Even when you're joining things that cannot be joined together, the system will still figure it out. Like now I can go back to this. The plus sign was failing us on that. Let me do a version where I use the concat instead of the plus sign. Take the concat. Now expose it to those two concepts. Give me this. And always remember when you're using the concat, use commas. No plus sign on the concat. Like commas, one, and then this. And then I'll run this and see how it's going to treat that. Yeah, you pull it up, you see. But then this fails because the concat function has an implicit process going on. Right? Implicit simply means something you did not state it. Right? Here we are telling the system, hey, this is an explicit process. We are stating that we want to change the data type of student ID. It's currently integer. We want to project it as a string, varchar 10. Run it. See, in the case of the concat function, you don't need to go through that painful process. Just run it. The system will recognize that, hey, this is a different data type, and it's going to go ahead and change it for you. You hit your target. See. So moving forward, if you need to fuse columns together, strings, just pass them through the concat function. If you want to add two columns together and they are numeric, yes, just stick to the plus sign. But when you're dealing with strings, you want to fuse things together, concatenation process, use the concat function. Right. So that's the terminology I was using. This is what we call explicit conversion. I use one of those functions to change the data type. See, I'm changing the data type of student ID from an integer to a string so that I can now join it to this string, join it to this other string, and there will be no confusion on data type error. See, explicit. I state the process, see, and it goes ahead and does it. Explicit. Implicit is when you don't state anything. See, this is implicit. The system just goes in there and recognize that hey, student ID, it's actually an integer. It will do the conversion for us. This is another version. You know how in universities you state a student's first name, last name, and you put their student ID in parentheses. See that? So I want to concatenate all of this. To understand this process, you have to follow the expressions one after the other. What is this? I'm taking the first name. See? After every expression, you put a comma. What is this? I want to put a space. What is this? I'm going to call in the last name. What is this? I want to put a little space and then put an open parenthesis. Let me first of all show you what I'll get without that space. So I'm going to put a parenthesis right here. And then I put another parenthesis right here. I'm enclosing that with my student ID. Let me show you what you get. You see? So exactly how we've stated it. Give me the first name with a space. This is first name and this is space. This expression is playing the role of that space right here. Then give me the last name, which is this. Then I did not put any space between last name and this. Every space should go in an environment. They start in the verbatim environment. These spaces right here, they don't count. It's not reflected. You're wasting your time if you do that. The system does not read those spaces. See? For anything you want to print out, it must go into that verbatim environment. Students always make this mistake. I want to show this in the query. See, you get an error. It doesn't recognize that being within within the non-verbatim environment. You need to put in this environment. Anything you want to print out in your output, it must go in this environment. If it's not a column, right? You see, this is very important. That's why you see this is enclosed. Right. The student was asking me, why can we not just do this and then come right here and do this? Right. It looks good. Let me remove this, but guess what? It will not be printed out. It is not in that verbatim environment. You're just wasting your time. See, it's not going to be printed out. Let me remove this and run it. See that it prints the column, but then the parentheses you wanted to see is not there. I want to get first name, last name, and the student ID in parentheses. The parentheses is right there, but the system did not print it out. See that? All right. So if you really want the parentheses to be printed around your student ID, you have to put it as an expression in the verbatim environment. Put a comma. See, then go to this other side. Put a comma. You separate it out. You see, so that the concat function sees this as an expression. Take this, concat it to this, concat it to this, concat it to this, concat it to this, and then concat it to this. See, that's how the concat function works. It identifies those as expressions. And now you see the parenthesis is showing up because we put it in an environment so that the system will identify it and print it out. I keep telling you this is a verbatim environment. Anything you type in this environment will be printed the way it was typed without any modification. That's a verbatim environment. You see it right there. So if you want parentheses, print it out in that environment. This is very important. You see, right? So if I run this is what I get. Now I need a space between my last name and the open parentheses. Just come right here and plug it in as a space and then run it and see the beauty of it. The space is there. After the last name, you see a little space before the parentheses. So if you're given this kind of task to perform in a company, you know exactly what to do. Right? The columns, things that are dynamic, driven by columns, just put the column name the way it is. Any other extra stuff you want to put them in that verbatim environment, like the space, the open parentheses, closing parentheses, and stuff like that. See? And based on this, I can now give you a business requirement to create the email of employees. I give you their first name and last name, build the company email. You can code that. So that's the beauty of the concat function. Just put the things you want to concatenate, just line them up and use a concat function. So we're graduating from that plus sign to combine strings together. See that? This is really, really interesting. Okay, let me see if this is just another repetition. But let me just skip this and go. Let's address this. It's a very important thing to address right here, and I'll explain it so that you can understand it. Let me first of all target the column the way it occurs. All right. One very important thing, since you're talking about conversion, one key thing is data type. Let me just introduce you to this. If you put your cursor on the asterisk, you'll see all the columns in that table will be listed out with data types in parentheses. PK means primary key, and then VACA, that's data type. Department name, VACA, that's data type, that's a string. Manager ID is a string. Location ID is a string. You see that? It's VACA. Now, if I want to do sorting on a string, you see there's a problem right here. I want you to sort out this table based on the department ID. You see, I put it on the other bar. See, this is a department ID. So give me the lowest department ID all the way to the largest one. That's what we expect to get. Let's see what happens when I execute this. It starts off nicely. Lowest department ID, that's the meaning of ascending. It skips and go to 100, you see. Meanwhile, there's a 20, you see. So it's messing up. It's supposed to go 20, 30, and then 40. As a data analyst, you will be very annoyed with this. It's not that you didn't code this correctly, but then it is not giving you what you expected. If you see this abnormal behavior, it's about the data type. That's the first thing you suspect. And again, if you just put your cursor on that column, it tells you the details of the column. Instead of going to the table and going to investigate what column is that and the data type, you see, this is a longer route. I have to go to the database HRO, go to the tables. What table am I looking at? I'm looking at the department table. This is it right here. I expand the department table, go to the columns, expand, and the table and the column I'm using is the department ID, which is this one. And that's when you see that department ID is not an integer. It has a physical appearance of an integer, but it is actually a string. So that's why I put this heading right here, sorting on a string. You're going to be wasting your time. If sorting on a string is from an alphabetical perspective. Strings can be sorted alphabetically A to Z. That's the meaning of this ascending. Or the opposite is this. It will mean from Z to A. So that's what the system is trying to sort this column on. It has the physical appearance of a number, but it is stored as a string. So sorting is not working. You see, descending will mean the largest department ID to the lowest. You see, it is still messing up. This could be very, very frustrating if you're working as a data analyst. But then the moment you realize that, oh, it's a data type issue, my department ID has the physical appearance of an integer, but then it is stored as a string. So when I put ascending, the system is reading this from an alphabetical perspective, A to Z, and there is no alphabetical layout on department ID. You see that? So that's why the sorting is not working the way we expect. You'll not go and complain to your manager and say, hey, this is going on. You see, no, just remember that there are functions you can use to change data types that are not in the format that suits your analysis. Right? So you will now step in on this order by and you transform the department ID from being a string, which is what it is, varchar, to being an integer. So that when you sort on the integer, ascending will mean the smallest department ID to the largest department ID. And that's how you hit your target. So that's the next segment right here. Change the data type of the sort column to integer. And this is also using the cast function, telling the system, hey, can you change department ID and project it as an integer? Right? You see, and now if I do the order by on this adjusted version of department ID, I start getting the outcome. Oh, this is always that stuff right here. Let me do ascending first, and then I'll switch to descending. You can see it's now working. We go from 10 to 20, 30, 40, 50, all the way to the largest. So ascending and descending are interpreted in the context of the data type. If you're working with first name, sorting on first name will be alphabetical order because it's a string. If you're working on salary, sorting on salary is going to be from a skill perspective, the smallest salary to the largest salary. It has nothing to do with alphabetical order. But if they made a mistake and stored salary as a string, then you will not be able to sort it in the format you expected it. You see, I really hope you understand this. These are easy things you can see in real life projects, right? So usually companies hire a database developer who is not an analyst. The database developer builds the database for the company. And then now they hire an analyst to come and analyze the data as they're coming in. All right, so the company has choose to store maybe a date as a string. And then somebody inputs a value that is not a date. The system will take it. See? But then when you start doing your analytics on that date column, you realize that hey, there's a value that is not actually a date. Right. You see that? So these things are practical problems you can encounter while working on real life projects in a company. So I want to pause right here and make sure we understand this. Like, you have to understand that this, just put your cursor on the column, it will tell you the information of that column. It says column name is what? Department ID. It's a primary key, and the data type is string, and it's not null. That's a mandatory column. When you're building databases, we're going to do that project later on. You're going to see how these things fit in. Right. I started this training on analysis. Right. There was supposed to be a phase where we build the database. I skipped that. Right. We're going to come back to it. Right. So this concept of data type is very important. Every column captures data of a particular type. Right. So department ID is captured as a string, as varchar, although it has the physical appearance of what? Numbers. See that? So that's why sorting on it, and I put ascending. It starts off nicely. It gives me the lowest, but then it skips to 100. Now it is supposed to go to 20. So we're supposed to have 10, department 20, and then 30, and then 40, and so on. You see? But then just realize, oh, it's a data type issue. Change the data type, and this is the formatting. The sorting is now working on perfectly. That's ascending. If I switch this to descending, I'm hitting my target. Largest department ID all the way to the lowest department ID. Nicely sorted. See? So pay attention to this whenever you're doing an analytics and the outcome is not as expected. Hey, there should be an issue on the data type. You can transform it. And there are two functions to change data type of any column, the cast and convert. Let me show you how the convert works. It's a little bit reverse. Convert, you state the data type you want to move to, and then you put the column you want to change it. It's kind of the reverse. I like cast because the way you read it is the way you type it in. Cast this column as an integer. See, that's it. But for the convert, you have to put convert, and then you put the targeted data type, and then you put the column you want to transform. See? So just remember this. When you use it a couple of times, you're going to understand that it's a little bit the opposite. And if you make a mistake and you reverse the order like this, take this and put it on this side, it's wrong. See, you get a syntax violation. Right, so it's just to use it a couple of times. So please take note, there are two functions in SQL that can help you to do data type conversion. This, I was supposed to put data type conversion functions to change the data type of any column. Right. So analysts do this every now and then. Like if you're doing an analytics and the column does not favor the kind of analytics you want to do, you switch it to the desired column, desired data type, and you continue with the analysis. So that's something new we've learned. Guess what? Let me go back to that question we solved earlier on the average star rating. I don't know if you remember that question. I think I have it on the chat window. Let me just go back to it. Average star rating. Yes, just go back. It's on the last message on the chat window. Average. Let me just paste it again. So now we have seen functions that can change data type. Yes, we can address that question. I'm just going to repeat the question all over again. Just copy it and then we do it all over again with better understanding. I'm putting on a new query window. This is a question right here. I'm going to paste it right here. So we're now going to be able to understand this much better. We are using the Amazon database. We are using in the reviews table. Select stuff from. Let me switch this to Amazon so that the system can pull up the table DBO. When I now do DBO, sorry, from first, then DBO dot from. Now DBO dot, let's target the reviews table. This is what we have. Now you have to understand that on the stars is stored as an integer. If you do an average on integers, you will never get decimals. See that? This is very important. So if you need to see those decimals, then you have to transform the stars column into a decimal or a float. A data type that supports decimals. Basically, integers don't support decimals. Right? This is very, very important. Right? Right? You can always reference this. 5 divided by 2, those are all integers. You get an integer. So the idea of telling you now to round this to the nearest 2 decimal place is just impractical because it's never going to project decimals. So that's the same issue we're going to run in this query, because we are going to be averaging on the stars column. Stars is stored as an integer, right? So before we perform the averaging, we're going to transform the stars column into a decimal of something that supports decimal. You see that? Okay, so let's go ahead with this. I'm going to repeat this process again. So given the reviews table, write a query to retrieve the average star rating for each product grouped by month. The output should display month. Remember, we have submit date, but they want us to project the month. See? So let's get to work. First thing, we're going to project the month from that submit date. That's going to be our first target. So I will use the month function right here on the submit date. And that's how we're going to get that month. See? I just call this as month. That's our first step. So we're showing each month, and what's the next thing? The next thing is the product ID. So display also the product ID. Right. So once you've captured the month, product ID, nothing will be done on that. The column is available. Right. Just project it. And then finally, what the average star rating. And it's telling you decimal, 2 decimal place. But we know that the average star rating was captured as an integer. This is very important. There's no way you're going to get decimals out of integers without transforming it. Right. So this is what we're going to do. Let me just go ahead and implement it and see the full picture, and then I'll come back now and do the transformation on the data type so you can understand it better. So ignoring that concept, we're just going to do average now on the stars column. And this will be the average star rating. Let me just put it right here. Just call it average rating. That's a long name. So again, this is going to give you an error. And in the question, they even told you to group by something. See? Right, you have to always recognize this. This is there are 3 columns: submit date, product ID, stars. The stars column has been aggregated. Product ID non-aggregated, submit date non-aggregated. This 2 has to go into the group by. The question even told you to group by month, but then by further analysis of that, tells you you're dealing with 2 columns they group by. First, this one. That's the first one. Put a comma. Second, if you stop right here just to prove a point, execute, you'll still get an error. You have to always group by all the non-aggregated columns on your select list. This is my select list, the list of columns on my select clause. There are 3 of them. 1 is aggregated, 2 are non-aggregated. The 2 must go to the group by. This is 2 right here. Stop right there and execute. You see that? And then now, if you now do the averaging, you see that you're not going to get any decimals out of this. Right, so there's a step you have to do before you aggregate, before you do the averaging. Transform this column into a decimal, so that when you average on decimals, you get decimals. When you average on integers, you will never get decimals. So this is what a data analyst will do. They will first of all dismiss the averaging, go ahead and project this column as a decimal. And best case scenario, we do the float. Right? Float is a data type that supports decimal. So there's another option called decimal. But this right here, you always need to go ahead and type some stuff in parentheses. But this still works. So this is casting stars as a decimal. I don't need to group by for now because no aggregate has been done. You see that? Right, it's still projecting that. And I can change this now to float. See that? No, don't run the group by first. Just run this, you see. Now, but then it's not projecting the decimals yet. But now when you apply the averaging on it, right? So now we're going to average on this conversion. This is very important. There are two ways to do this. I can just cut this off. I prefer this and then start typing. We want to apply the average function now on that conversion. See, now if I run this, see what we're getting. You start seeing those decimals showing up. Right, I need to put the two. Right, I need to put the two. So step by step, this is what we did previously. Averaging on the stars yields no decimals because the stars column is an integer. So you see no decimals in the outcome. Right, no decimals in the average outcome, the AVG outcome. Right. Why is that? Stars column is an integer. See, you cannot get decimals out of integers. This is very important thing. Put your cursor on stars. It is an integer. You're wasting your time if you run this. It's gonna always still be an integer. Right, and then if you even continue now to float to render it in 2 decimal place, you don't first of all have decimals. How do you want to proceed to render it in 2 decimal place? Right. So to get the stars in the decimals, first of all, transform. So look at this step right here. So step 1, let's transform or convert decimal or float. These are 2 data types that will support decimals. Either you do decimal or you do float. See in this, this is before you get to the averaging. Right, let me just do it step by step so you understand. And then at this point, we don't need our group by. So before we get to the averaging, don't do it after averaging yet. You have to do it before the averaging. See, it's not projecting it, the decimals yet, but it's actually in a decimal format. Right, see? Right, and then now you can now do apply the averaging on the transformed. Right, so in step 2 for this process, apply AVG function on the converted or the transform on the transform stars column. See them? So that's why I wanted to do this separately. And at this point now, we can bring back our group by. Because why? Because this is now going to be taking an aggregate function. So this is what I normally do. I kept this off. Type the AVG. This is an aggregate function, so you have to watch out each time you use any aggregate function. You have to inspect the other ones. If they are non-aggregated, make sure you put them in the group by. So this is me adding them now to the group by, one after the other. This is the first one, group by that, comma, second one, group by this. So now you see we are averaging on the transform stars column, and see what we now achieve. The decimals are now showing up. See that? And then finally, now let's address this part of rounding up into what? 2 decimal places. Rounded to 2 decimal. See, that's the last part of that question. That would be this part right here. Let me put step 3 right here. So we're going to apply the round function so as to address this requirement, which says that we should round the outcome to 2 decimal places. See that? So we need a round function. Again, you're going to be targeting this. See, always keep this, keep preserving what you've built, and then keep applying the functions on what you see. Now I can just call my round function. I copy that, I carry it off, and then I can apply my round function, and then what am I rounding? I'm rounding this expression right here to 2 decimal places. The idea of cutting it off, it helps, because if you just want to type the round function on it, you're going to get confused with the number of parentheses, right? And always remember, the number of open parentheses must balance with the number of closed. So if I count the open ones, this is 1, 2, 3, open, close, 1, 2, 3. So sometimes you have an error, you forget about this one, it gives you an error. Right. So whenever you start nesting functions, putting a function inside another one, it gets messy if you don't really stay on point on that. See, so it's always better to cut it off, build the incoming function. See, I want to round. What do you want to round to 2 decimal places? I want to round the expression I built previously into 2 decimal places. You see, it fits in nicely. And now this is it right here. You see that? Remember, in this one we had 4 point something something, 4.3. This is a previous step right here. 4.30. You see that? Yeah. And this is now the rounded approach to that. See that? Or you can also use so this is step, this, I can do another version of this step. We talked about the format function today. Let me get this off right here. And instead of using the format function, the round function, let me apply the format function to this. Let's format this right here as a number into what? 2 decimal places. Now let's run this version and see how it works. See, I like this version. This thing is even going to be better when you put them next to each other instead of putting them on separate queries. All right, let's take this right here and put it next to this one so that you see it in the same query next to each other. It is better than when you separate them out. Right, you see that? So I have now one query with the 2 options, and now you can judge for yourself which one is really performing better. Is it the round function or the format? You see, the round function just preserves this one, 5. You see, but then, and most managers hate this. If you're projecting something to 2 decimal places, then do 2 decimal places. Don't do 2 for some, nothing for others, 1 for others. See, this is just mixing things up. Some managers are very strict when it comes to building dashboards. You have to be consistent. If they want something to be projected in 2 decimal places, you better deliver on 2 decimal places. See that? So that's why sometimes I hate the round function, because it fails you just when you need it. Right, but then the format function is actually doing a good job. If you look at this, this is, you see, it's 2 decimal places, consistent across all. The round function is not consistent. Are we together? You see that? So if you're dealing with that very strict boss, a strict manager, yeah, and if it's just what it happens in companies when you start building dashboards, you see consistency. Don't be showing me one decimal place right here, three decimal on this side. No, you have to be consistent. See that? And that's the same. You see, if I look through these dashboards, you see consistency in the way things are done. You have to be consistent when you're dealing with formatting. See that? And that's just the problem I have with this round function. But then the format, you see, it delivers. See, I put it next to each other. You see, this is what it means to render something in two decimal place. It's consistent, right? So I didn't want to go deep into that part in the first area because we didn't look at the convert function, the cast function. So this is very important. This is how you work as a data analyst. Don't complain that, hey, the database administrator has to dedicate somebody to go change stars from an integer into float before you can now step in and do your work. They chew everything and give it to swallow. No, you can use these functions and do your job. And remember that the fact that you've run this query, we've changed stars from an integer to float, it has not changed the data type in that table. If you go back to the Amazon database, go to tables, go to the reviews table, expand and go to the columns, stars is still an integer. On our analysis for this particular query, we have rendered it as a decimal, a float. This is very important. These functions don't go into the original table and change it. It's still integer. See that? But then at the level of our query, we've transformed it, right, just to meet this requirement. This is very important. Just imagine every requirement you go and change the data type. You're just messing things up, right? But then you can do it for that particular requirement at the query level. Right? Let me pause right here. I've been explaining a lot. Let me pause right here and see. First, let me share this right with everyone, and I'll give you some time to just go through the steps. And if there are questions, let's address them. And I know you have to create more time and then go over them back at home, quiet environment. Yes, but then just take a moment and go through the steps. And then if you see an area that needs further explanation, I will happily address it. This is very important. Companies have data that is not in the right structure. One or two things are always going wrong. And if you interview any data analyst, they'll tell you they spend a lot of time on data cleaning, that is prepping data for the analysis. Right. So things don't always they're not always given to you in the clean format, in the right format. You just apply your analysis. So this data type conversion functions, the cast and the convert, you have to know them. See that this is very, very important. Okay, so let me pause for a while and please take a moment and just rush through this and then see if there are any areas that need further clarification, especially when it comes to nesting these functions. You see, doing a lot of nesting one after the other. You see. Hey guys, any question on this? I'm just going to copy this and add it to the lecture material. So this is a good example of a question where you can use one of those data type functions to do the transformation before proceeding to do additional steps. Okay, I'm just going to put it right here before we get into the lower and the upper functions. Functions are a little bit scary when you start working on them, but then by the time you focus on the critical ones and understand them, right, you will never be able to know all the functions. That's just the truth, right? But then what I'm trying to do, I want to expose you to those ones that you should know upfront, right? I still keep learning new functions. It's a very broad topic in SQL, right? Okay, so let's see what we've covered. We've talked about these two. We've talked about the concat. I'm just going to go over a couple of these. I don't want to make the class too long today. We've talked about so many functions and it's getting really maybe too much on you guys. Yeah. And you can now understand why the concept of functions is being treated across 2 weeks. This weekend and the next weekend again, we're going to come back to functions. Right. So it just shows you how broad this topic is. Right. Probably just going to talk about two of these counterpart functions. These two, yes, these are two of the same kind of counterpart functions. So this one's right here, and then we can just call it a day for today so that we can round up on the string functions. So we've talked about the concat. Let's talk about the lower and the upper. If you know the lower function, you definitely know the upper function. These are counterpart functions. And this terminology lower is in terms of the case, uppercase, lowercase. So for example, this entire string right here, I want to type it as a lowercase. So every single letter should go in lowercase. That's all about the lower function. And then the opposite is what the upper function is about, the case of the letters. This is very important. Nothing strange, nothing hidden about that function. If I just type in something like that, you see, I get all of this in a mixture of upper cases, see, uppercase followed by a series of lower cases and then upper cases. But then if I want to be consistent throughout, I want every single one of these letters should be lowercase. I just simply expose that to the lower function. That's all it does, you see. It projects, you see, S, capital S is now small s, Q, L, or every single thing. This is no exception. And there are just two options. Either everything goes lowercase or everything goes uppercase, right? So this helps also in data cleaning, formatting, right? You can, some requirements, the manager will tell you, hey, can you project all of these letters in uppercase? And there's a function for that. So that's all you need to remember. And that's why it's good to know a lot of these functions so that when you have these requirements, you can know, okay, I know of an upper function, uppercase function, just apply it if needed, lowercase function, just like that. So these are what we call counterpart functions. If you know one, you know the other. Because this is doing the direct opposite of this one. This is doing the direct opposite of this one. And that's all about this function, pretty much. I have this string written all in uppercase. That's how the data has come in. I want to build a report or do some analysis where I need all of this should be projected in lowercase. It's a lower function. Just apply it to that string and project it. Everything goes lowercase. That's all you need to know on that function. You see that although there are several functions, but some of them are straightforward, easy for you to just recognize them and hold on to them, and that's it. All of this is in lowercase. I need all of these letters to be projected in uppercase. I use the upper function and then just display that, you see. End of story. That's it. Right. So these are, like I said, counterpart functions. If you know one, you know the other. See, it's just the direct opposite of the other. And it's really that simple. Let's embrace that in a table. Let's connect to HRO. So let's assume we are dealing with Microsoft employees. You see, all of these employees in this table, we are dealing with the Microsoft employees. Let me just put a table right here for exploration purpose. So we're dealing with Microsoft employees. We have the first name, last name, and they want you to use that information to build the official email, which is going to be, for example, in this person, first and last name, is going to be the official email is going to read like this: Stephen.king@microsoft.com. You see that? Just take the first name, put a period, take the last name, and then you add this extension to it. So this is going to be the same for everybody, this extension. So the only thing that's going to keep changing is what the first name, which is column driven, there's a column right there, and the last name, which is also column driven right there. So before you attempt to solve this question, you have to understand what is going to keep changing the dynamic aspect: first name, this part, last name, and every other thing is static. And how do you print out a static component and put it in a string environment? And then now you have to link all of these three things together. There are many, actually more than three. I have this, which is first name. I have this static. I have this, which is last name. I have this entire thing static. And now you remember there's a concat function. Just dump all of those things inside. Comma separate them. This right here is going to generate this for each employee. Every employee has their first name. So you're going to project the name. How do you get the dot? It's not column driven. It's just a static something. Just put it in this verbatim environment. You see, you're building it gradually. Last name is column driven. This part is going to come from a column. Just put the name of the column right there. What about this part? It's going to be the same for everyone. They're all Microsoft employees. So this email extension is going to be the same for everyone. And we just hard code that. And that's the string environment right there. Verbatim, you see. And that's how you build the email as requested by the business. This is it. See that? Right. And then next, it can tell you, hey, after doing that, can you project all of that email stuff into uppercase? You see, we have a mixture of lower and uppercase. Just make it consistent. Project everything uppercase. You just now apply your upper function to everything you've built previously. That's how nesting functions work. You nest a function inside another. This is the logic. I want to render all of this uppercase. And that's it right there. Everything right there should be rendered uppercase. See, that's it. Run this. Every single letter in the email that we built is now uppercase. If you want to do the opposite, that's lowercase, lower function, render that. See, this is really, really interesting. Right. So you see the power of that concat function. Just pass in the expressions you want to fuse together or concatenate them. We no longer need to rely on the plus sign. Right. Just call the concat function, and then you list out the expressions one after the other with a comma. Go to the next one, put a comma. Go to the next one, put a comma. Go to the next one, and that's it. The system will put all of that into a single column, and that's how you build your email based on the business requirement. If they want you to project all of that in an uppercase, yes, you can do that. Upper function delivers right there. Change that all to lowercase. Yes, it's a lower function. That's all I'm trying to do in this session. Expose you to this function so that you can just call them when you need them in any analytics you are performing. See? Right. This is still a repetition all the way down, just repeating that concept. There are two more. This one's Friday, just streaming. Yeah, those are the last three we're going to talk about, and we can end for today. There's this function called len. This is simply counting the number of characters in a string. This is Texas. 1, 2, 3, 4, 5. So if I apply the len function onto Texas, This function will simply go into this and count 1, 2, 3, 4, 5. And then if we get this outcome 5, that's the number of characters in that string called Texas. See that? So please don't take note, we are counting the characters, the number of characters. Spaces are also counted. Anything that is in a symbol form is also counted. Right. Now, when it comes to spaces, there's something I have to mention. If the spaces at the beginning it counted, at the back, I think it will be ignored. I'll address that later on. Now, if I now put the city, comma, the state with the space in between, comma will be counted, the space will be counted. Let's just go ahead and count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, if I do the len function on that concept, I get this number, the number of characters in a given string. If you're dealing with a table, you just pass a column, it will count the number of characters in each of the values in that column. All right, how many characters are in this string? The len function will count that for you. You don't need to keep counting them, you see. Same thing, right? And then this is right here is what we call a leading space, a space that occurs in front of a string. So this is no space, neither in front nor at the back. Leading space is what you see right here. And there's a reason I'm talking about the leading space, because if it's present, the len function will count it. These two will give different counts because this has no space. It's the same word, Texas, Texas, but this has a space. You see the space is inside the string environment. It will be printed and it will be counted, you see. So these two counts are different. This one is 5, this one is 6. The 5 one, of course, no space, 1, 2, 3, 4, 5. This one that reports 6 is because of this space. See, that space is counted, we get 6 for that one. No space on this, we get this. So the leading space is counted. Now a trailing or a lagging space is when you have it at the back of the string right here. This is trailing the string, it's trailing the text, lagging space. Now this one has no space, no lagging space. This one has a space at the end. But then look at the counts. The same. So when the space occurs at the end of the string, the len function cannot detect it. But when the space occurs in front, it can detect it. You see this one has no space. I'm showing you the standard and then the one with the anomaly. So you can see the difference, 5 and 6, because of that space in front. This one has no space. This one has a space right here. It's not going to be counted. So hence we get the same number of characters. So that's just one disadvantage with the len function. It's not able to detect the space at the end of the string. But when you put the space in front, it will detect it and count it. See, this one is going to give you 6. The 5 characters in Texas plus the space 6 in front. But then this is going to count the 5 characters in Texas and stops right there. And even if there's a space, it's not going to count it, even if you expand it. See, right there, it still retains 5. Right. But if you do that same stuff right here, 6, I extend 1, 2, 3, 4 more. It will count the 5 in Texas plus the 5 spaces in front, 10, you see. So when the spaces are in front, it spots it and detects it, counts it. But when they're at the back, like what we had right here, it will not be able to detect. It's going to treat these two as the same, 5 characters each. Right. Okay, I think, yeah, let's just end here. I'll come back to this function. We've covered too many functions today. I'm going to push this 3 to next class together with these ones. So next week is still going to be functions. But we're going to see some different ones. Let me go to week 5, no, week 6. Let's see the objective for week 6. You're still going to see more functions. These are extractions functions, logical functions, and then we get to the window functions. So more functions are going to come next week. And these are very important functions, right? Okay, so that's the plan. But on Wednesday, we're going to have a lab session on the functions we've just covered so that we can prepare ourselves for the next sets of function, which is going to be on week 6, right? So I want us to end here for today. right? So that I can give you some time to catch up on this. You really need to sit back, maybe watch the video and study this. Use W3 Schools and online resource, the lecture materials to catch up on these functions. Right? Some of them are really easy to know upfront, but others you need to read further about them and then So Wednesday I will be coming with projects so we can review this. I'm just going to go over this website and see if we can have more questions to solve using the functions we've seen so far. Right. Okay, we're going to end here for today. Any question before we go?
Not from me. All is good on my side.
Okay, so hopefully, like I said, functions are a little bit tricky. I don't want anyone to get discouraged on this. Right, this is really, really important. And if you can, as you see, we gradually heading towards those advanced topics. I really don't like using that word advanced, but you know, it is what it is. SQL is divided into basic, intermediate, and then advanced, right? So you're gonna be seeing these ones on the 7th and the 8th week, right? String functions right here. This is a concept of cover to the string functions, right? But then I don't want you to read. Oh yeah, these ones are similar. Upper, lower. We've talked about this today. Yeah, it's in line with this PostgreSQL. SQL T-SQL recognizes upper function and also lower function. Same. Let's see another one. Yes, left and the right. This is a week 6 function we're going to visit. And then the length, these guys talk about length, but then in T-SQL is length, not the full spelling, you see. So it's kind of in line, you see that. What else? So you see the length function is counting number of characters, 1, 2, 3, 4. That's why it reports 4 right here. For this one, black widow, count everything with a space, it goes to 11 characters. But in the management studio, if you project this to this, you see, it doesn't recognize that. You see, this is not a recognized built-in function. So these are just some little things that sometimes agree on both versions of SQL, like the left and the right function. We're going to see that next week. Today we've seen the upper and the lower. These are just cases, functions that transform cases either upper or lower. Trim, this is valid, it's still the same. We're supposed to cover this today. I just push it to next week. Right, it's in the list of the string functions. You see the streaming. So this PostgreSQL recognizes those. Why is that still? Yes, so PostgreSQL still recognizes those. Right, concat, we've seen concat today. Right, concat function, we've seen that today. Substring is a function we're going to see on week 6. Yes, week 6, we're going to see that in week 6. These are the left, right, car index substring function. These are week 6 requirements. So you can see this is the advanced part of SQL. And it's advanced true, but it's something within reach. You just need to create more time and go over it. Right. So these are advanced topics we are addressing the last 4 weeks of the training. Okay, so let's stop right here and we're going to address some of this from a project perspective during the lab session on Wednesday. Right. But I'm very happy we're making progress and just create time, keep studying this. I don't want anyone to give up. Right. The challenging part is the SQL. You're going to relax and have a lot of fun on the Power BI side, on the visualization. Right. Okay. So see you on Wednesday.
Yeah, thanks for today. See you on Wednesday.
See you on Wednesday. Yeah.